Welcome everyone. In this lesson, we will study Archimedes' principle, which is part of the fluid mechanics topic. This principle helps us understand why some objects sink, some float, and some appear lighter when submerged in liquid. Let's begin by looking at what happens when an object is fully submerged in a fluid. Here we consider an object that is fully submerged in a liquid. When the object is placed into the liquid, two main forces act on it. The weight of the object, acting downward, and upward force from the liquid, known as the buoyant force. These two forces determine whether the object sinks or stays suspended in the liquid. The force exerted on an object when it is submerged in a fluid is called the buoyant force. Buoyant force is an upward force acting on an object immersed in a fluid. According to Archimedes' principle, the buoyant force is equal to the weight of the fluid displaced by the object. This upward force explains why objects feel lighter when placed in water. When an object is immersed into a container that is completely filled with water, some of the water spills out of the container. This spilled water is called the displaced fluid. An important concept here is that the volume of fluid displaced is equal to the volume of the object. This idea is very useful when dealing with objects that have irregular shapes. One important application of Archimedes' principle is in measuring the volume and density of irregularly shaped objects. Since we cannot easily calculate their volume using formulas, we use fluid displacement instead. Instruments such as a hydrometer work based on this principle, where the buoyant force balances the weight of the object. Archimedes' principle is also applied in submarine design. When the submarine's ballast tanks are filled with air, the buoyant force becomes greater than the submarine's weight, allowing it to float on the surface. When the ballast tanks are filled with water, the weight increases and the submarine dives to the desired depth. This shows how engineers control buoyancy in real-life applications. For an object that is fully submerged in a fluid, the buoyant force, Fb, is equal to the weight of the fluid displaced. Mathematically, this can be written as Fb equals the density of the fluid times the volume of the object times the gravitational acceleration. This formula allows us to calculate buoyant force directly. Another useful way to calculate buoyant force is by using weight measurements. When an object is submerged, its apparent weight is less than its actual weight. The buoyant force can be calculated as Fb equals Wo minus Wa, where Wo is the actual weight of the object. Wa is the apparent weight in the fluid. Let's look at an example. An object weighs 143 newtons in air. When fully submerged in water, the spring scale shows 130 newtons. The density of water is 1,000 kilograms per cubic meter. We are required to find the buoyant force, the volume of the object, the density of the object. First, we calculate the buoyant force. Fb equals Wo minus Wa, then we get 13 newtons. Next, we calculate the volume of the object using the formula and substituting the values gives. Vo equals 1.33 times 10 to the negative third meters cubed. Finally, the density of the object is calculated using the formula and we get 10,960 kilograms per meter cubed. This example clearly shows how Archimedes' principle helps us determine physical properties of submerged objects. An object fully submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced. This principle is essential in engineering applications such as ship and submarine design, density measurement, fluid mechanics, and construction analysis. Understanding this concept helps engineers design safe and efficient structures involving fluids.